What's going on, guys? In this video we are going to see an example on Newton's law of cooling. Let's look at this problem. Here this question is asking a pot is baked in a kiln and emerges at a temperature of 300 degrees Celsius. This is our body temperature, and then into a workshop that is constantly at a temperature of 30 degrees Celsius. This is the surrounding temperature or room temperature. So whenever they give a room temperature or anything, that's surrounding. After 1 hour, the temperature of the pot is 100 degrees Celsius. So after 1 hour mean T of 1 is equal to this one. Okay, T of 1 is equal to this one. Assume Newton's law of cooling. The first question is asking what will be the temperature of the pot after 2 hours. The second question is asking how long will it take until the pot cools to 32 degrees Celsius. Now let's look at the first one. First one is asking what will be the temperature of the pot after 2 hours. Now the generic, you have to know the generic equation in order to do this problem. That is T of T is equal to T E, or we can say TS. In this case we are saying surrounding, right? Environment or surrounding, you can put TS plus T body minus T surrounding again e power KT. Now this information is given because it's useful for us to find out this K value. Then only we can solve for 2 hours, right? Because we know the body temperature and we know the surrounding temperature. We know everything except this K. If we can find the K, we can create a generic equation that can be used to calculate any time. Like we can calculate the temperature at any time. So that's why we need to find out the K using this information. Now let's go ahead and apply that one. T of 1 is equal to T surrounding. Let's plug the values. T surrounding is 30 degrees Celsius. 30 degrees Celsius. Let me note that one down to T is equal to 30 degrees Celsius. T body is equal to 300 degrees Celsius. And then T of 1 is equal to 100 degrees Celsius. Now here we have T of 1, that's 30 degrees Celsius. Let's avoid the unit for now, because all of them are going to be Celsius. Okay, plus TB, that is 300, minus again T surrounding, that is 30, e power KT. K we don't know, T is 1 because we are looking at 1 hour, and we also know T of 1 is equal to 100. We can plug it right here. 100 is equal to 30 plus 300 minus 30, that's 270, e power K times 1. Now 100 minus 30, that is 100 minus 30, 70, that's equal to 270 e power K times 1. Therefore e power K is equal to 70 divided by 270, and so here e power K, but we want to find out what is K is, so we have to take ln both sides. Ln e power K, that's equal to 70 over 270. Now ln e power K, so here this K goes to the front and ln of e is 1, so we will get, I have to take ln both sides in this side also, so K is equal to ln of 70 over 270. Okay, now we just have to find out what is this is. Let's simplify, or we can just simplify as ln of 7 over 27. Ln of 7 over 27. Now we have a generic equation because we know all of these values except T. Like we can express a general equation like T of T is equal to T surrounding is always going to be the same, 30, and T body minus surrounding, it's always going to be the same, 300 minus 30, that's 270, times e power KT. We found out K, that is ln of 7 over 27, ln of 7 over 27, okay, and times T. So this is our generic equation. Now here the question is asking what will be the temperature of the pot after 2 hours. Now we just have to plug 2 instead of this T. T of 2 is equal to 30 plus 270, and here one more thing to consider. E and ln, here we have E and ln cancels each other and we will get 7 over 27, but you have to notice that this ln is only applicable for the 7 over 27. This is not with t, right? That's a common mistake. So this E and ln cancels each other, so we will get 7 over 27 and this t still remains as power, okay, because this is not belongs to this ln. So we will get 7 over 27 power t, and here we know that t is equal to 2, so we just put square right here. And if you simplify and calculate this one, you will end up with 48. This is t of 2. Now we have solved this one. Now let's look at the second part. Second part is asking how long will it take until the pot cools to 32 degrees Celsius. Now they have given this information. They have given this information and they are asking us to find this t. Okay, let's go ahead and apply this equation again. Let's get rid of this, all of these things. Okay, I use the same equation here. T of t, that's what given, 32. 32 equal to 30 plus 270 times. Okay, here I made a mistake. This is times, but the final value I calculated right. This is times, not plus. Okay, so 270 times e power ln of, oh, I can directly put it as times 7 over 27 power t. T is what we are interested in finding. Okay, and if you rearrange this equation, like if you bring this 30 to this side, this is going to be 2 is equal to 270 times 7 over 27 power t. Therefore 7 over 27 power t is equal to 2 over 270. Now we have this one. Now to bring this t to the front, again we have to take ln both side. Ln both side. If we take ln both side, we can move this one to the front. So in that way we will get t times ln of 7 over 27 is equal to ln of 7 over, actually 2 over 70. Therefore t is equal to ln of 2 over 70 divided by ln of 7 over 27. And if you calculate this one, you will end up with 3.6 hours. And that's how we do that. And if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch it too. And there are a bunch of videos on Newton's law of cooling too. So go ahead and watch them. And thanks for watching. Don't forget to subscribe. See you next time.